This is problem number 8 from section 9.4. In this problem it says when 3 pumps A, B, and C are running together, they can pump 3,100 gallons per hour. When only A and B are running, 1,800 gallons per hour can be pumped. When only A and C are running, 2,000 gallons per hour can be pumped. What is the pumping capacity of each pump? So I think we can just easily use A, B, and C as our variables. So A plus B plus C equal 3,100 is one equation. Another equation would be A and B are running, so A plus B, that's going to equal 1,800. And finally, when A and C are running, that's going to equal 2,000. Now I imagine that we could solve this numerous ways, of course. They're probably wanting us to use Gaussian elimination here. So let's go ahead and use Gaussian elimination. So we'd end up with 1, 1, 1, 3,100. We're making an augmented matrix here. We end up with 1, 1, 0, 1,800 here. And 1, 0, 1, 2,000. All right, first step we want to take is we want to cancel these both out to be 0. So I'm going to take -1 times R2, and I'm also going to do -1 times R3. And when we do that, we get -1, -1, 0, -1,800. We get -1, 0, -1, -2,000. We still have 1, 1, 1, 3,100. Now I'm going to do R1 plus R2 equal R2, and R1 plus R3 equal R3. So when we add this one with the bottom, we end up with 0, 1, 0, 3,100 and 2,000, that's 1,100. Now we do R1 row 1 with the middle, that's 0, 0, 1, and then 3,100 minus 1,800, that gives you 1,300. And then we still have 1, 1, 1, 3,100 on the top. Now you'll notice this is telling us Z is 1,300 and this is Y is 1,100, but it's out of order, right? So we don't have the ones down the diagonal. Well, these are just equations and they can be switched. So I'm just going to switch those two equations, the order they are, and you'll see that now we've gotten ourselves into ones down that diagonal. So this is 0, 1, 0, 1,100, and this is 0, 0, 1, 1,300. So you can see, although it didn't look that way, here, we're actually at the point when we have ones down that diagonal, so we've essentially done Gaussian elimination. Now we can do the backwards substitution if we want. I'm going to go ahead and do the backward substitution. I'm going to say that Z is 1,300. That's Y is 1,100. And the last equation is X plus Y plus Z equals 3,100. So I can plug both of those in. So it's X plus 1,100 plus 1,300 equals 3,100. Subtract those over. So we have X plus 2,400 equals 3,100. We subtract that over, we end up with X equals 700. So now we were using X, Y, and Z. I kind of screwed that up. That should be obviously A, B, and C. So this is actually A, this is B, this is C. So we'd write that as 700. I'll just put A above it. 1,100, which is B, and then 1,300, which is C. So pump A pumps 700 gallons per hour. Pump B, 1,100 gallons per hour. Pump C, 1,300 gallons per hour. Those are the solutions.